Good morning to all. I am starting with a new lesson, that is P block elements. First PUC you studied what are P block elements, what is their general electronic configuration. Then out of 13, 14, 15, 16, 17 and 18, 13th and the 14th group elements among the P block elements you have studied. Whereas this year we are going to study 15, 16, 17 and the 18 group elements. 15 group is nitrogen family, which is also known as picogens. Then 16 is oxygen family, which is called as chaperones. Then 17 is fluorine family there, which is called as halogens. Then 18 is of the helium, neon, etc., which is called as noble gas, also known as inert gas or rare gas. Before starting, just tell me, what is P block element? When I go for this nitrogen, if you see 1s2, 2s2, 2p3, the last electron enters into the p orbital or p subshell. So it's a P block element. Carbon 1s2, 2s2, 2p2. Again just here, last electron enters into the p. Or the boron 1s2, 2s2, 2p1. So an element in which the last electrons, so this nitrogen, oxygen, fluorine or the carbon, boron, they are all P block elements. One mark question will be there in the first main. Then three mark questions. Means this is 1 mark, this is 9 marks. Totally 10 marks will be asked. Among the second PUC topics, the weightage is highest for this chapter, for the annual. Question number 20, 21, 22. 3 questions will be there. See, already I discussed 13, 14 group element in the last year syllabus. This year's syllabus I am going to start with 15 group elements. The 15 group element, we call it as picogens. Why no? The compound of this compound have some chalking effect onto the nose, or some chalking smell will be there because of that picogens. Irritating smell producer, generally is producer. What are the members? The first member is the nitrogen with atomic number 7. At 8, 15 is the phosphorus. At 18, 33 will be there for arsenic. At 18, 51 for antimony, and at 32, 83 for bismuth. The next member, add again 32, 115. So I can write with a U, P. So as this member the first member, I can say that one as the nitrogen family members also. Now, where we can get the nitrogen? 78% of the atmospheric gas is nitrogen gas only. Whatever that present in atmosphere, around 21% is oxygen gas. Means this again it becomes 99% altogether. Only these two gases. The remaining 1% will be there with the noble gases, carbon dioxide, etc. But the major constituents are these two gases only, nitrogen and the oxygen. Now, where else we find the nitrogen? Animal and the plant contains the nitrogen. In animals, in the protein, we have the nitrogen over there because proteins are polymers of amino acids, and the amino acid contains the nitrogen, NH2 group. So plant also contains that nitrogen. NaMO3, which is child salt peter. CO, there is a nitrogen. Then potassium nitrate, called as Indian saltpeter. Again, nitrogen is there. Sometimes competitive exam question can be there, like among these, which does not have the nitrogen? One is in the appetites. Probably you can have. What is appetite? Ca3PO4 2 times CaX2. This is the general formula of appetite. You can replace with the fluorine, then it becomes fluoroapatite. If you replace with the chlorine, chloroapatite, where X can be F, chlorine, even hydroxyl group also. Note on this properly. Ca3PO4 twice, CaF2, fluoroapatite. Ca3PO4 twice, Cl2, chloroapatite, etc. They contain the phosphorus group. Actually, it is a calcium phosphate. That will be there in the phosphate rocks. Phosphoprotein will be there in milk and egg. Then our bone contains phosphorus, arsenic, antimony, bismuth are present in sulfide minerals. NPK, fertilizer, you might have heard. So, nitrogen, phosphorus and potassium are the macronutrients. Mean that nitrogen and the phosphorus are there in the 15th group only. Electronic configuration. What is the electronic configuration of the p block elements? Noble gas NS2 NP126. This is for p block elements. Whereas, what is the electronic configuration for the 15th group? Nitrogen, which is the 7th element, I can write it as helium where 2 electron already over, 2s2, 2p3. Then 15th element is phosphorus, identical with the neon, 3s2, 3p3. Then after that what I have, 33 is arsenic. I have argon configuration. Then 3d10, 4s2, 4p3, because d orbital filling takes place. Then 51 is antimony. Then again krypton configuration, 4d10, 5s2, 5p3. Many make the mistake. What they write is krypton 5s2, 5p3. Wrong, because there is a filling of 4d electrons. And it may say 3d, is that this krypton only. Then 83 is bismuth, xenon. Then I have write 4f14, 5b10, 6s2, 6p3. Remember this fact. Here filling of f orbital electron also starts. So 4f14 will be there. So if I write the general one, what I can write is noble gas configuration ns2, np3. Note all this properly. They may give certain example like bismuth, write the electronic configuration. Like that question also can be there. Okay? Yes. Atomic and ionic radius. How they varies? See, boron, carbon, nitrogen, oxygen, fluorine, neon. What is studied? Along the period, size decreases because more and more electrons are added to the same shell. And from the fluorine to the neon, there is an increase. Why this increase? The completely filled electron will be there in the neon. Inter-electronic repulsion will be there. So, among the period, halogens have the smallest size. Each period. Biggest for the first member, alkali metals. Not for the noble gases. Nitrogen size is smaller than carbon but bigger than oxygen. Carbon is bigger than the nitrogen, boron is bigger than the carbon. Nitrogen, phosphorus, arsenic, antimony and the bismuth. See, nitrogen 1s2, 2s2, 2p3, only 2 orbitals are there. But the phosphorus 1, 2, 3. More and more shells are added up down the group, means your size increases down the group. Size increases down the group. But one point you have to remember, nitrogen to the phosphorus, how much increase will be there? That much increase will not be there from the phosphorus to the arsenic. Higher increase, ratio, lesser increase. But nucleus 1s2, 2s2, 2, 2p1, 2p2, 2p3. This is for the nitrogen. Phosphorus 1s2, 2s2, 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. 1, 2, 3, 4, 5 electrons. See, in the nitrogen or the phosphorus, there is no d or f orbital electrons. First you studied one thing. D or the f electrons are the poor shielder of valence shell electrons. Screening effect will be lesser for them because of their diffused orbital size. Effective nuclear charge, here also effective nuclear charge will be there. But as the more inward ion in the phosphorus, so nitrogen to the phosphorus size increases drastically. Now, take this example now. This is phosphorus, you say 1s2, 2s2, 2p1, 2p2, 2p3, 2p4, 2p5, 2p6, 3s2, 3p1, 3p2, 3p3. Now, arsenic 1s2, 2s2, 2p1, 2p2, 2p3, 2p4, 2p5, 2p6, 3s2, 3p1, 3p2, 3p3, 3p4, 3p5, 3p6, 3d1, 3d2, 3d3, 3d4, 3d5, 3d6, 7, 8, 9, 10. Then have your 1, 2, 3, 4, 5. See what happens now? This d orbital electrons are the poor shielder of valence shell electrons. So what they do is they attract this electron to the more extent to the nucleus. So what is the increase in the size here will not be there in this case. Relatively lesser increase will be there in this case. But definitely size of this arsenic will be bigger than size of the phosphorus. 100% sure. Whereas when you go for this arsenic to the antimony, again size increases. Then from the arsenic to the bismuth, what happens? From the antimony to the bismuth, what happens? There is a F electron introduction also, and F electrons are the poorest shielder also. Means still the increase becomes less compared to the these increase over there. Ionization enthalpy. See, nitrogen has ns2 np3 configuration. Means nitrogen family members of this configuration, and this is exactly half-filled configuration, so more stable. Means ionization enthalpy of the 15th group element are relatively higher than 16th group element also. Because what it says, along the period ionization enthalpy increases species. With that factor, I should have had boron less than the carbon, less than the nitrogen, less than the oxygen, less than the fluorine, less than the neon. But this order will not be there. Boron less than carbon, less than oxygen, less than nitrogen, less than fluorine, less than neon will be the correct order. This is due to presence of half-filled configuration, proper symmetry factor. Proper symmetry, more stable. So to remove the electron from this, we need more energy. So remember this fact properly. Now down the group, ionization enthalpy decreases because size becomes bigger and bigger. Electronegativity. You know that electronegativity is boron less than the carbon, less than the nitrogen, less than the fluorine, less than the fluorine. Means 15 group element have the lesser electronegativity than the 16 group, which in turn less than 17. Then electronegative nitrogen is greater than the phosphorus, greater than the arsenic, greater than the antimony, greater than the bismuth. Because down the group electronegativity decreases. Electronegative enthalpy: phosphorus greater than the nitrogen, greater than the arsenic, greater than the antimony, greater than the bismuth. Because second period element have lesser electron gain enthalpy than the third period element because of the what? Very small size of the second period element, anomalous property.